Hi guys, welcome to the final episode of this chapter. In this episode, I am going to talk about consumer surplus. Consumer surplus is a very important concept in applied economics because most of the applied works aim to understand how different policies influence consumers or the people in the economy and their welfare. All right, so the question is, how do we measure welfare? Well, we measure them by measuring the consumer surplus. Well, the question is, what is consumer surplus and how do we measure it? Well, if you remember from your intermediate micro or principles courses, consumer surplus is the area between the price line and the demand curve, right? So if this is a demand curve, right, this is your standard quantity versus price curve. If this is your price, we know that this area is what's called consumer surplus. If we are talking about a change in price and how that affects the consumer surplus, so let's say this is let's say this is initial price, this is final price. So initially that was Q initial and then finally Q final. So this area is basically the change in consumer surplus, right? Remember, so the area between the price line and the demand curve always gives us the consumer surplus. The question is, where is this idea coming from, right? I mean, why the area between the price line and the consumer surplus demand curve is called consumer surplus. What does it really mean? One. Second, what demand curve is this? I mean, at least in this course up until this point, we learned there are at least two ways of measuring demand: compensated demand, or the Hicksian demand, or the Marshallian demand. So which demand curve is this? So hopefully we're going to clarify all this. And on top of this, we are going to learn two new concepts: compensating variation, called as CV, and equivalent variation, called as EV. And they are important concepts to understand consumer surplus. Sometimes some economists actually measure welfare by using these concepts rather than consumer surplus. Okay, so how do we start? What is our starting point? Our starting point is a comparative static analysis, meaning we change the price of a good and then observe how the demand of this good changes, and from that calculate the surplus. So what does that mean? That means we start with an initial price for some good X, and then we change it and call it PF, a final price for the same good. And suppose, without loss of generality, the final price is higher, so we increase the price of this good. Okay, so its consumption will decrease, obviously, if it is a superior good. Okay, well, obviously I'm keeping everything else: price of good Y, if there are more than two, price of the other goods fixed, income is fixed, etc. So again, for simplicity, let's suppose that there are two goods, because drawing everything in a two good world is easier. So this is good X, this is good Y, and this is the utility level when my consumer consumes X initial and Y initial, all right? Y initial. At this, I know that the optimal budget line, not the optimal budget line. The budget line is something like this. I'm not completing the budget line, and I know that its slope is Px initial divided by Py, right? What I know is that now I'm changing this price, Px final, which is a bigger number. So therefore the slope, the absolute value of the slope, is going to be higher, which means the new budget line is going to be steeper or more perpendicular to the horizontal axis. Okay, so what I want to do, I want to fix this consumer's utility level so whatever initial utility he gets out of consuming Xi, Yi. I'm going to fix this utility level and then try to find the minimal expenditure needed to achieve this utility level. All right, so I'm basically solving an expenditure minimization problem. That means my new budget lines are going to look like this, where the slope is minus px final divided by py. But there might be more than one, remember, because I am not equating my budget line equal to some income. The income part is varying here. Only the utility is fixed. So therefore, assuming that I'm going to have an interior solution without loss of generality, let's suppose the new budget line or the new expenditure line and the indifference curve are tangent to each other at this point. I'm going to call this xf, and this is the yf. Okay? So if I translate this into my demand curve, this is x, good x. This is the price of good x. So what happened initially, I had xi, and then I have x final. So the initial price was lower. So this is pi, price of good x initial, and price of x final. So this is where I'm basically drawing the demand curve. Hicksian demand curve. We know how to draw the Hicksian demand curve. We learned this. So the Hicksian demand curve, so these 2 points basically corresponds to these 2 points on the Hicksian demand curve. All right? Very good. Well, what else? Well, the thing is, I am actually going to show you that in a moment by using the Shepard's lemma. This area is actually the change in the consumer surplus. This is the area is in the change in the consumer surplus. Why is that? As we know, all right? So you may say, so that demand curve that we were keep talking in the intermediate micro was Hicksian demand. Well, not really. So here is why this area becomes the consumer surplus. Well, first off, this is what I am going to define. So remember here, what I'm doing is I would like to keep this guy utility level fixed, all right? So I am calculating this guy's final expenditure, px final, py, u bar. And then I calculate his initial px initial, py, and the u bar. So this is how much basically income he had, right? And this is how much, additional income maybe, not additional. This is how much income he needs under the higher prices when the utility level is the same. Well, I know this is higher than this for many goods. Why is that? Well, if you want to keep the guy the same utility level at a higher prices, you have to give him a higher income. All right, so this expenditure is going to be above this expenditure under the normal goods. So anyway, but I want to look at the difference. So how much additional income I need to give this guy, or how much money I should compensate this guy so that his level of utility stays the same even though price of good X has increased. So let me repeat. This difference is how much additional money I should pay to this customer to keep him or her the same level of utility, same level of happiness, although the price of good X has increased. Okay, so we call this compensating variation. As simple as this. Okay? Well, what I'm going to do is the following. Look, if you remember the Shepard's lemma, the Shepard's lemma says the compensating variation, the Hicksian demand under Px, Py, and the utility level U bar is in fact the partial derivative of the expenditure function under Px, Py, and the utility bar divided by the price of good X. Right? Yeah. Okay. Well, then what I want to do, I want to integrate both sides. That shouldn't change anything. integrate and sum with, so let's clear this part because I'm done with these graphs. Okay, so before I integrate, I'm going to rewrite it because I need a bit space. So this Hicksian demand is equal to del expenditure px py u bar del px, right? So I'm going to take the integral on both sides. That shouldn't change the equality. And some sort of an infinitesimal sign with dpx, I'm sorry, dpx. So dpx. Okay, so what does that mean? That means, oh, and by the way, so this is a definite not indefinite integral. So you know what? The price was initially px initial, and then it's px final. So I increased px initial to px final. All right. So what I do have is sort of simple, right? So this guy, oops, the how much additional money I need to give this guy to keep his level of utility fixed, although I change the price from PXI to PXF, that is basically, therefore, nothing but, so this is basically the compensating variation, right? Compensating variation, all right? And this is nothing but the area below the integral. So this is my compensated demand curve, XC, PX, PY, and U bar. So it basically says, look, this is my PX initial, this is my PX final. So therefore, this compensated variation, which makes sense because, as I said, the idea is the following: how much additional money I need to pay this guy to keep his level of utility same. And this amount of money should be equal to the area below the below his compensated demand curve, and between the prices, initial price and the final price. So this area, right? If you remember the integral, this integral is nothing but this area. All right. So this is exactly how we define consumer surplus. All right. So the consumer surplus is therefore, well, I mean, I'm going to come to this. The formal, not formal, but the consumer surplus you learned in principles in intermediate micro was different. I'm coming to there. But, well, this is how we sort of measure how much, how much the consumer needs to be paid to keep his level of utility the same. So it makes perfect sense. It's the area below the compensated demand curve. All right, but the problem is we cannot observe compensated demand curves, right? I told this at least a few times. So the reason why we can't observe it is because this is a function of a parameter u bar, which we never observe. But what we do observe is the Marshallian demands, px, we observe prices and the income, and then we can then estimate the Marshallian demand curve. So the thing is, instead of drawing the Hicksian demand, can I just draw the Hicksian demand, Marshallian demand curve, and do exactly the same analysis, PXI, PXF, and so this area is kind of not exactly the same, obviously, because remember, Hicksian demand curve and the Marshallian demand curve are not exactly the same. They are same at one point, but other than that, they're not the same. But nevertheless, can I call this somewhat equal to a compensating variation, and then define this consumer surplus? Is it a fair treatment? Is it a fair measurement? I know this sounds like a perfect idea to measure consumers' change in consumer surplus, right? Because how much money I'm going to pay to this guy. So if I increase the price, he's basically losing that much money, all right? I'm not compensating him, right? His income is fixed, but because I'm not compensating him, he must be losing that much money, quote unquote, or that much welfare if I increase the price. So can I use this idea, but instead of the Hicksian demand, apply it to the Marshallian demand and say, hey, this is how I need to measure the consumer surplus in welfare analysis? Well, yes, but here is the reason why we can do this. I need 5 more minutes, hopefully. So, I shouldn't erase that. So the initial price for good X is less than initial final price of good X. So here I am going to define another concept, equivalent variation. All right. So what is equivalent variation? So here is what it means. The equivalent variation is how much money that the consumer is willing to pay to return his old situation. When that's going to be clear when I picture this graph. So let's consider the Marshallian demand curve. All right. So this is X. So I'm going to denote it a function of Px, Pyi. So you understand that this is a Marshallian demand. So remember the initial price was this guy. Let's suppose Pxi. So I'm going to call this point A. So what happens is, and this is X initial. What happens is, well, the price is increasing, and so his Marshallian demand is going to be XF. All right, so these are Marshallian, not Hicksian. Be careful. So in the previous graphs, I had the same XF, XI, but they were Hicksian. These are Marshallian demands. Be careful about this. So, so what I can do, so I know, for example, at this point, there's going to be a Hicksian demand curve. All right, so this is the initial point, right? X initial Px. So this is going to be a Hicksian demand curve. So, or the compensated demand curve, calculated at price X, price Y, and instead of income, it's calculated at utility initial. So what is utility initial? Is basically utility function of this guy under Xi, Yi. Okay, so if you consume this, if you choose this consumption, the Marshallian demand, all right, you're going to get some utility. So at this point, your utility is U initial, right? And so this is the Hicksian demand curve when the utility level, that U bar, is fixed to Ui. All right. Remember the Hicksian demand curve and the Marshallian demand curve intersect with one another at that point where the income is exactly equal to the expenditure of getting this utility level, which is V of, yeah, that's better. V of Px, Py, and Ui. All right? Oh, income, I'm sorry. Income. Okay, so now remember the price of good X has increased to this point. All right, so let's call this point B. And at point B, this consumer is going to be getting probably less utility, right? I mean, how do I know that? Well, look, I mean, his income is fixed. Nobody's giving him money. So his income is fixed and now price is higher. So one good is more expensive. So he should be consuming less of this good, at least maybe also less of the other good. So his utility should be decreasing unless he has a weird utility function, obviously. So therefore, this is another Hicksian demand curve calculated under, okay, here's the important part. So this is Px, all right. So these are Px initial, right, under the initial prices. So this is final price, okay? Price of good Y is still the same everywhere because we don't change it. But this is a Hicksian demand curve, so this is U final. So under the new utility level, okay? So once again, the Marshallian demand curve and the Hicksian demand curve intersect at the point where the u of f is in fact equal to the indirect utility px final py and the income I. So the income I is still the same. This is also px initial. All right. So therefore, I'm using this property that Hicksian and the Marshallian demand curves intersect one point when this holds, and then basically drove these three lines. Again, they are not indifference curves. These are demand curves. This is the Hicksian demand. This is the Marshallian demand. This is the Hicksian demand. All right. So let's put number here. This is A, B. I'm going to call this C and this point D. And then I'm going to call this, Q, and I'm going to call this R. So if you remember our compensating variation calculations, well, the compensating variation was basically telling us that this consumer's sort of how much we need to compensate this guy if we want to keep his initial level of utility UI is basically this area, right? I'm going to tell you this, Q, C, A, R, right? Q, C, A, R. So this big area is the compensating variation if we want to keep this guy's level of utility as his initial utility. However, However, if I want to keep this guy's utility as the same as his final utility level, well, then the amount of money I have to give, give this guy is Q, B, D, and R. All right, so this sort of smaller area versus this bigger area. Well, I have different color, but I'm just worried that the colors may, okay, not so bad. So this is the blue area. So this is the blue area, and the smaller area is this area. All right. So the question is, when we calculate the consumer's welfare with CV, the compensating variation, right? How much money we need to compensate him. The question is, which utility level are we going to take as the base utility level? Should we take the initial utility or the final utility as the base utility level? Well, there you go. The Marshallian demand curve, you see that? Okay, if you do this analysis, like the area between the price lines and the demand, Marshallian demand curve is the how much compensation we need to offer this guy. So this area, however, the alternative or the Marshallian demand is actually this area, Q, B, D, R, which is definitely less than Q, C, A, R, but it's greater than Q, B, D, R. So it's somewhat, it's not perfectly, but somewhat in between these two areas. So you can think of calculating consumer welfare by using the Marshallian demand is somewhat taking average, loosely speaking, taking average of calculating the consumer surplus with Hicksian demand curve, but the Hicksian demand curve has the problem, what should be, remember, because when we calculate CV, it was like expenditure, P initial, PY, U initial, minus U bar, let's call it, and then expenditure, PX final, PY, that was initial, that is final, I'm sorry. Usually we have final minus initial, U bar. So what should I assume this base utility level, U bar? Should it be U initial or should it be U final? All right, so that's the idea of therefore, using the Marshallian demand curve is somewhat taking average of these two. Well, remember this is what we call compensating variation. But there is also a concept which I haven't formally defined, so let me clear this. The equivalent variation. So this big area is actually what we call equivalent variation. So equivalent variation is how much to pay to return to the old situation. So basically, equivalent variation is in fact the following. The expenditure when the initial price PYU initial minus expenditure PX initial PYU final. All right. So given those initial prices, so how much money is this guy willing to pay to go back to his initial utility level? Well, the thing is, this guy is equal to the expenditure of PX final PYU final. All right. Well, yes. Well, why is that? Well, because remember the expenditure, when I'm sorry, I cleared the graph, but let me very quickly draw it again. So that was the Marshallian demand, PX, PY, and then the income. So this is the initial. So that was X initial, that was X final, that is PX initial, that was P final initial. So remember, so the expenditure at the initial price, PY is always same, the same utility level. Well, this expenditure must be equal to the income, right? And also the expenditure at the final price, this is PX final, I'm sorry, the PY and the final utility level, well, this should also be equal to income, this expenditure, because the income of this guy is still the same. So for that reason, we write the expected equivalent variation as the difference between the expenditure under PXF, PYUF minus expenditure PX initial, PYUF. All right. So remember the compensating variation was basically, expenditure PX final PYU initial minus expenditure PX final initial UI. All right. So therefore, if we take the initial utility level as the base utility, so the CV is going to give me this big area. All right. That small area is therefore, in fact, so that CVF guy is in fact nothing but, we give a special name to this, equivalent variation. And so the question is, should we use compensating variation or equivalent variation to calculate the consumer welfare? Well, if you use the Marshallian demand curve and the area between the price lines, well then that area is going to be somewhat average of these two. So therefore, and on top of that, because you can't observe the Hicksian demand XC, using the Marshallian demand curve and finding this area and naming it as a changing consumer surplus is a reasonable assumption. So because of this, we use the Marshallian demand curve to calculate the consumer surplus. And the idea of consumer surplus comes from these two terms, compensating variation or equivalent variation. Basically, how much should we compensate this guy so that we keep his utility level fixed, or put differently, how much this consumer is willing to pay or how much we can tax him so that he can return to old situation, the EV. All right, so I hope that was clear. With this, we basically finish the demand theory. And I hope to see you in next episode. Bye-bye.